Let's talk about forecasting. It's the art and science of predicting the future, and it's what shapes multi-million, sometimes billion-dollar decisions every single day. I mean, from deciding how many iPhones to make to predicting energy demand for a whole city, getting it right is absolutely critical. But getting it wrong? Well, as we're about to see, that can be catastrophic. And you know, the frustration in this field is real. This quote from forecasting expert Dr. Valery Monacan just perfectly captures the high stakes. I mean, can you imagine 2 years of your life, countless hours, all down the drain because a popular, hyped-up model just couldn't handle the real world? And believe me, this isn't some rare story. It really shows the massive gap between theory and what actually works. But what happens when these failures scale up? Okay, let's talk about Zillow. They launched this massive iBuying business, right? So basically, they were using machine learning models to predict housing prices and make instant cash offers on people's homes. But their forecasts were fatally flawed. It led to a spectacular collapse, the shutdown of the entire division, and thousands of people losing their jobs. That's the market value Zillow lost. $50 billion. Just let that sink in for a second. I mean, that number is just staggering, and it really drives home how devastating a bad forecast can be. This wasn't just a small error in the math. It was a fundamental failure to understand the risks and the limits of their models. So after hearing about disasters like that, you might be thinking forecasting is just some kind of dark art, right? But it's not. And to avoid those pitfalls, we've got to bust some myths about what forecasting really is. And this is really the key difference. You've got the crystal ball, fortune telling on one side, and on the other, you have the hard data, the charts, the actual science. True forecasting is planted firmly on the side of science. So let's get a clear definition. What is forecasting, really? Well, it's the science of anticipating the future. And how does it work? Simple. We systematically analyze historical data, we find patterns that repeat, and then we use those patterns to project what might happen next. It's a structured, disciplined process. And this right here is probably the most important point to understand. See, fortune telling is all about trying to be precisely right, to give you that one single magical answer. But real forecasting, it has a completely different goal. Its goal is to be reliably uncertain. It's not about certainty, it's about understanding and managing the range of what could happen. It's about confidence, not magic. So how do we actually do that? It all starts with this one fundamental idea. Basically, any data you collect over time, think daily sales, stock prices, whatever, can be broken down into just two parts, a predictable pattern and unpredictable randomness, what we call noise. The entire job of a forecaster is to model that pattern and then put a number on that randomness. You know, this desire to predict the future, it's not new. It's about as old as humanity itself. So let's take a quick trip through time to see how we went from reading omens in the sky to running complex algorithms on supercomputers. So check this out. This is the Mayan Dresden Codex. The Maya were incredible astronomers. They meticulously tracked the cycles of Venus, not just for farming, but to decide when to go to war, when to hold sacred rituals. They were literally performing an early kind of time series analysis just by watching the planets. Okay, fast forward to the 20th century and boom, things just exploded. You have guys like Slutsky and Yule who came up with the first autoregressive models, which is basically a fancy way of saying using the past to predict the future. Then, during World War II, you've got Norbert Wiener figuring out how to filter noise from radar signals. Why? To better predict the flight paths of enemy planes. Super critical stuff. Kolmogorov gave it all a rock-solid mathematical foundation, and way later, Engel and Granger even won a Nobel Prize for figuring out how to model long-term financial trends. Suddenly, prediction wasn't just an art anymore, it was a hard science. So that amazing history has left us with this incredible toolkit, which brings us to the modern day. The best way to think about the models we have today is like a spectrum. On one end, you've got simple, easy-to-understand statistical methods. And on the other, you have incredibly complex deep learning and even foundational models. Those are the huge AI models that can be adapted for all sorts of things. The real skill, the mastery, is knowing which tool to pull out of the box for which job. Because trust me, there's no one-size-fits-all answer here. And here's what that contrast looks like. On the left, you've got your basic statistical models. They're transparent, we get how they work, which makes them great for stable, predictable patterns. And on the right, deep learning. These things can feel like a total black box, but man, they are wizards at finding really complex, hidden patterns in just massive amounts of data.
Okay, so this table breaks down the trade-offs really nicely. Your statistical models, super easy to interpret, but they kind of assume the world moves in straight lines, which it often doesn't. Machine learning, it can handle all that messy nonlinear stuff, but yeah, it's often a black box. It's hard to know why it made the prediction it did. And then deep learning, it's the king when it comes to sequential data, but it takes a ton of computing power and it's even less interpretable. It's always a balancing act.
But here's a really crucial point. You don't always have to pick just one. In fact, the really state-of-the-art stuff today often involves creating hybrid models. So you might use a simple statistical model to nail down the big picture, the overall trend, and then you layer a machine learning model on top to predict the more complicated stuff left over. You really get the best of both worlds.
So, with all these powerful tools, you'd think forecasting would be a solved problem by now, right? Well, not quite. It's still a really hard discipline, and it can be pretty humbling, to be honest. The reality is, being a good forecaster means you're constantly navigating this minefield of hurdles, and any one of them can totally derail your project.
Let's just run through them real quick. First off, data quality. What do you do when your data is messy or just plain missing? Then, what happens when the world just changes? A pandemic hits, a new competitor pops up, and suddenly all your past data is basically useless. Then there's picking the right model. How do you find that sweet spot without making it way too complex? And maybe the biggest one of all, how do you explain the uncertainty to your boss? How do you get people to trust a prediction from a black box model?
And all of this really brings us to the ultimate takeaway. See, mastering forecasting isn't just about being some tech genius who can code a fancy algorithm. It's about being a strategist, someone who can navigate all that uncertainty, adapt when things change, and make smart, practical calls. So, I'll leave you with this thought. We have tools that are more powerful than at any point in human history. But let's be real, none of them can actually predict the future. So that begs the question, is the real goal to build the perfect model, or is it to get really good at mastering uncertainty itself?